welcome to day one of trig. We'll deal with trig for a long, from now we'll deal with trig until we get done with school in the spring. Okay? So a trigonometric function, if you will, has an angle measure as its input. Louis, earbud out. Okay? Has its angle measure as its input. So the independent variable is an angle. The output is a real number. Okay? So we're going to input an angle measure into our function. So all of our x values from before are now going to be angle measures. Our outputs, our outcomes, our results, if you will, are now going to be real numbers. Okay? Trig has two different units of measure. Okay? The first unit of measure is degrees. So our angles can be in degrees. And you've dealt with degrees. You all came through geometry at some point in time. And you know that around any point there's how many degrees? 360 degrees to make a full complete circle. Okay? And why did they choose 360 degrees? Was supposed to fly away. But alas, it didn't. Right? So why 360 degrees? The long answer is it's the sexagesimal counting system with base 60. Okay? The short answer is 360 is one of those nice numbers that a lot of numbers go into. 2, 3, 4, 5, 6, 8, 10, 9, 9, 10, 12, 15, 18. A lot of numbers go into it. So that means we can divide it up into a lot of equal, even, nice parts. Okay? So some measures. Now, one of the things that if you came through Algebra 2 Extended, you probably did a little bit of unit circle building with them. Okay? We're going to redo most of that. Not today, but we're going to redo most of that in the next coming weeks. Okay? So, in trig, put degrees in red. In trig, 0 degrees is out there, straight out to the right. Okay? We'll confuse you in a few months by switching to navigation. And navigation has 0 degrees straight up. North is 0 degrees in navigation. Okay? Positive angles, oops, I should go like this. I should go like this. Positive angles go counterclockwise around the circle. Negative angles go clockwise around the circle. And it used to be really nice because we used to have a regular old analog clock in the room. And I would come over and say, clockwise is how time goes. Clockwise. Counterclockwise. Okay. So if it's 0 all the way around, then would be 360 degrees. halfway around would be 180 degrees. Half of half would be 90 degrees. 270 would be down here. Half of half of half would be 45. So there's, if we quarter it, and then half the quarter, or eighth it, if you will, we would get 45, 135, 225, and 315. Those are all in the positive direction. If we go in the negative direction, then this would be negative 45 degrees. This would be negative 90 degrees. Negative 135 degrees. Negative 180 degrees. Negative 225 degrees. Negative 207 degrees. Negative 315. Negative 360. And all of those measures can be put into a trig function. And the outcome would be a real number. Good stuff. Good stuff. Now, the second unit of measure we're going to discover right now using Smarties. Okay? A whole bag full of Smarties here for us to use in a minute. Okay? So, I need you, if you need paper, I've got paper up here, but we kind of wanted you to put it in your notes. So I need you to start a fresh page of notes right now. And you want to have, like, if it's in your notebook, leave it be in your notebook, because when you're using compasses, you don't just want to have the sheet of paper, like, on the table, because then it slips around. You want that pointy end to actually go into some more paper, and you want to be in your notebook. Okay? So what I need you to do is somewhere right smack dab in the middle of your paper, I need you to put a dot. Just a single old dot right in the middle of your sheet of paper. Okay? Then I need you to draw. You were supposed to pick up a ruler, okay? So using your straight edge now, I need you to draw a line to one of the edges of your paper. I don't care if it's top, bottom, left, or right, okay? From your dot, draw all the way across to one, top, bottom, left, or right. I don't care which one you go. If you go, if you know, you know. If you don't, you know. If you got it, here we go. Now, it is very imperative that you do not eat your Smarties until I tell you to eat your Smarties, because you will need your Smarties for this activity. Okay? And if you don't have all of your Smarties, you cannot do this activity. Oh no, I'm dropping Smarties!
Or I'll take them out.
I'll take them.
They're not dumb. Oh no, it's dropping more on the floor!
That's probably where my Smarties are. The floor.
Incoming. 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 Everybody's got Smarties now? We'll save the floor Smarties for later.
I'll take the floor Smarties.
Floor Smarties.
Floor Smarties are the greatest. wrapped in plastic.
They're wrapped in plastic. Yes. So at this time, what I would look, I gotta get to the same point that you were at. Okay, so at this time, what I would like you to do is I would like you to carefully unwrap your Smarties so that we can utilize them. Again, don't be Linsmeyer. Come on. I can, because my Smarties are already on the board. Okay? What I would like you to do is I would like you to take 7 Smarties. 7 Smarties and line them up on, whoa, tap the brakes. And line them up on your line, starting at your point, edge to edge. So we're going 7 Smarties wide here, along on your line. Three, 6, 7. 7 Smarties wide on your line. Okay? Okay? That, now what I would like you to do is on your line, take your pencil, put a little mark at the edge of your 7 Smarties, because then your Smarties are out of the way. Okay? Now what you're going to do is, where's my tool? In that one? Nope, it's not in that one. It's in, not in that one. Not in that one. And where's my compass tool? I used to have it. There's my compass. Okay? So now what you're going to do is, slide your Smarties off to the side. Okay? So that is going to be your radius. So pointy end at your dot. Extend your compass out to the edge and draw said circle. Okay? So now, remember, you started with 7 Smarties. Okay? So now what I want you to do is I want you to pick any point on your circle, and I want you to put an X on that point, or on the circle, I should say. So I'm going to pick my X, and I'm going to put my X right there. It can be anywhere on your circle. Okay? Now, with your 7 Smarties, what I'd like you to do is, starting at your X, I'd like you to break your circle up into groups of 7 Smarties. So what I mean by that is, I want you to take those 7 Smarties, starting at your X on the circle, and I want you to go all the way along your circle. So there is one grouping of 7 Smarties. So I would then mark that, and I would say it's right there. And then I would continue that all the way around the circle in groups of 7 on your circle. Oh. Okay. So it shouldn't have gone all the way around, shouldn't have been able to divide it into equal parts, right? One reason why, what's 360 degrees divided by 7? Not something pretty, right? Okay, right? Now, is that the reason that we chose 7? Never know. Okay?
Sure.
Never know. Okay? Right? So we ended up with, or I should say I ended up with, I got 1 part of 7, I got 2 parts of 7, I got 3 parts of 7, 4 parts of 7, 5 parts of 7, I got a 6th part of 7, and then I got this little chunk in here, right? Which, if I look at it, that's about 2 Smarties wide, right? At least my chunk is. I don't know about yours. Okay? NASCAR, what did you come up with? About 2 Smarties wide?
Mine is about 1.
About 1? Okay, a little off. And that's, it varies. Depends on how tightly knit your Smarties are. Okay? Like for mine, it all depends on, like, if I had, and for you the same way, if I go there, now I got a smaller distance on the circle kind of a deal, you know, so there's a couple of different things there. Okay. 2 Smarties. Okay, so what's 2 divided by 7? Anybody? So we got 6 and what did you say? 2 divided by 7 is 3.5? I didn't think so. 2 divided by 7, somebody with a calculator, please. 7 divided by 2 is 0.2857. So we've got 6.2857 groups of 7. Right? 6.28. Sounds familiar. Anybody? What do you got, Joe? 2 times pi, right? Okay. Because pi is usually like 3.14. Okay. Anybody know what the circumference of a circle is? Diameter times pi, right? Okay. Or 2 pi r. Well, what was our r in this case? 7 Smarties, right? So 2 pi r would be 2 times pi times 7 Smarties. So that's where that comes from. What we actually just discovered, and what we're going to rediscover here momentarily, we're going to do it again, except this time we're going to go inside that circle, is we discovered the second form of measurement, of angle measurement in trig. And that is the radian. The radian, 1 radian, is a measure of the central angle theta that intercepts an arc, which we'll call that arc length S, equal in length to the radius r of the circle. Where's my, there it is. So in this case, if we are finding the radian, my arc length S has an equal distance to my radius R. So how we go about finding that angle is we first find what the, oops, oh no, stay there. We first find what the radius is. So that is my radius. Then we take that radius, because a compass, you may think a compass is for drawing circles, but a compass is actually for measurement. It's a way to measure things this lengthwise, the length of it, of an object. Okay? That's what the true part of a compass is, or true purpose of a compass. Okay? So I just measured out my radius on my circle. Now, this here, this arc length, that arc length is S. Here is my R. So the angle that gets formed right here, this angle is 1 radian. One radian is the angle that gets formed to go 1 radius on the edge of your circle. There are 2 pi radians in an entire circle. We just found that right here. We found that there were 2 pi radians to get, or 2 pi Smarties to get all the way around our circle. So and what you had told me before was that there were 360 degrees in a circle. And there are 2 pi radians in one circle. So if I take 360, if I find what the ratio is, if I take 360 and divide it by 2 pi, I would get the degrees in 1 radian. Somebody with a calculator, please. We'll round to 4 decimal places. 360 divided by 2 divided by pi. Don't go divided by 2 pi unless you put the 2 pi in parentheses. Divided by 2 is 180. 180 divided by pi is, what do you got? 4 decimal places. 57.2929.
Sorry, 2957.
58?
Yes, 58.
So 1 radian is equal to 57.2958 degrees. And it takes 2 pi radians to complete 1 revolution. Just like it takes 360 degrees to complete 1 revolution. Okay? So now we could have angles that measure 1.5 radians. Okay? And we can use that in our trig formula, or our trig function, excuse me. In the trig function, most of the time, it is used in radians. And radians are going to be your unit of choice going forward. Okay? So, what I would like to do now is I would like to verify all of this information. So back on your 7 Smarties graph page, or your 7 Smarties circle page, okay? Now, I would like you to verify that with 5 Smarties. So it should be a smaller circle. It should be inside of your current circle. We can set it up the exact same way. But now put 5 Smarties on your line. Measure your radius. Draw your circle. Measure or divide it up into chunks of 5 Smarties all the way around. And see if we get the same result. So after you got your 6 groups of 5 all around your new circle, and then your open gap should be 1 Smartie left, okay? Then you can start eating said Smarties. Okay? Last thing is I want to explore here a little bit that the whole relationship of radians and degrees. So once again, we said that there were 360 degrees around the circle, and there were 2 pi radians around the circle. So if we make that become a ratio, radians over degrees, we would have 2 pi radians over 360 degrees, which would reduce down to pi over 180. And this pi over 180
Or if we reciprocated the entire process and we went degrees over radians, then we'd have 180 degrees over pi, is going to be very beneficial for you, and one of those things that you should just flat out memorize. Because if I am converting from degrees into radians, then I am going to multiply by pi over 180. If I am converting from radians to degrees, you are then going to multiply by 180 over pi. Because that would cancel out the degrees. That, I'm not going to lie to you, is something that we will use frequently. And it's one of those things, it's one of those things that when we tell you to memorize it, we want you to memorize it because we are going to use it lots. And then I don't have to answer the question in 2 months, how do I convert from radians into degrees? Because, can I borrow your protractor for a second, Joe? Because the downfall with a protractor is there's only degrees on the protractor. There's no radians. So we can't necessarily know exactly what the degree measure is. Or sometimes we ask for things in degrees, but they're given to us in radians. And so there's lots of things with measure. Questions, comments, concerns, clarification? Hearings. Yes, ma'am.
So each radian is 6.28, or that's all together?
Altogether, there's 6.28 radii, because radii is the plural of radius.
Okay.
There's, it would, to go around every circle, it's 6.28 approximately. So it's 2 pi.
Right, so the
Radii to get around.
So the 6.28 is equivalent to 360 degrees?
No. 6.28 is just how many radiuses it takes to get around the circle. So if you take your circle and you cut it and you lay it out on the ground, okay, it would take you 6.28 radiuses to get from one end to the other.
Okay, but the radian can be divisible by different amounts. Like we did 7 Smarties and 5 Smarties.
It doesn't matter what the radius is. It's always going to be 6.28 to get all the way around. Yep, and that's why we did it 7 and 6. If we would have done it with 3, it would have been 6 Smarties and then like a fraction of 1 to get around.
Okay.
Yep. About a half of 1.
So we had like one radian equals 57.2458.
Yep.
All the time.
All the time. Twice on Sunday. Yep. Because if we would divide this right here, 180 divided by pi, it's 57.2758. Okay.
Why twice on Sunday?
Because.
So the 57 degrees is equivalent to 1 radian.
1 radian.
Radian. Okay.
Radian, which is the amount of length it takes to get a radius on the arc of the circle. I know, throwing out a bunch of math terms today.
Well, they all start with R.
I know, exactly. Yeah. Okay?